Okay, so we are about to start. Karol for Kubernetic, right? He will talk about how to reach out to application deployed on our Kubernetes cluster with the open source software. So, huge shout out to Karol.
So, hello everyone. Thanks for attending this talk. The title is Enabling Multi-Cluster Load Balancing with Gateway API and Envoy Gateway. And so, some words about me. I'm Karol Szwaj. I'm currently software engineer at Kubernetic. I've been around in Kubernetes space for 8 years already. I've been contributing to many open source projects, and also I'm maintainer of Envoy Gateway. Born in Gdańsk, still living there, and yeah, I'm Polish, so yeah, happy to see you all. And today we're gonna talk about Kubernetes networking, right? Everyone knows it's simple, and everyone loves it, right? Nothing really happens to it, and whenever it happens, it always a DNS is a fault, right? Yeah, but also we have these cool layers in our Kubernetes world, right? We don't have like a simple solution, because why not? To access our application, this actually image is something I really like, and I always showcase this. So we have like tons of layers we have load balancers, ingress, kube proxy, service, sidecars, and then we have the application, which is like a clue of our business models or running our production. So yeah, Kubernetes networking today, I'm gonna only include this topic, like two top layers. It's load balancer and ingress, because I couldn't have much time to explain all the kube proxies, service meshes, sidecars, and how connected to each other. So we're gonna really talk about how to get the traffic to your cluster. So actually, let's start with some refreshment, how the traffic actually gets in the Kubernetes cluster. So we have service, right? Service is used for exposing our application and getting traffic into it. We have a first type of service, is the default one, is a cluster IP. So the traffic goes through the proxy, whether it's IPVS, IP tables, or eBPF, whatever you use underneath. Of course, CNIs are there, but we're gonna not include in this talk. And another one is a node port. So node port exposes random port from the range 30,000 and opens up the port to like for on every node, so the traffic can access the port directly using the service of type node port. Another one is a service type external name. This is really like just a DNS alias. So we have a CNAME that we define our external service, which we want our pods to get connected to, and we use that to find this service and connect to it. And the last one is the load balancer. It's a special case of our node port services, but it has like an external implementation that provisions the load balancers in our cloud environment. So it also opens the port, but we also configure the load balancer, which is in the cloud or our private on-prem deployment, and we deploy it. So we're gonna really focus on this type of service today. And of course, before like going further, we need to talk about a bit of an ingress. We use that to get our traffic to the Kubernetes clusters. We use the ingress controller, which set up if we had, I guess, service type of load balancer and we specify ingress controller watch that, and in the ingress resource we had defined ingress rules that specified how the traffic should be routed and connected to the external load balancers and configured itself to really consume the traffic and configure the routing back to our pod. Now, how about another variable? Let's say, like, why not? It's not even complex enough, right? So let's add the Gateway API. How many of you already are using Gateway API? Some of them. How many guys heard of Gateway API? Okay, so it's getting there. So it's like a CNCF initiative. It's coming emerging standard for ingress traffic. And it's also managed by the SIG network community in the Kubernetes world. So the guys responsible for everything in networking this decided to start off this, let's say, project or initiative. And why is that? We know Ingress had some of the problems. One of them is it had limited functionality out of the box. And so other features needed like vendor-specific configuration, and also that was configured by great numbers of annotation. I think anyone saw how the implementation looked like. I think HA Proxy or Nginx had like a 200 of annotations to configure traffic, which, yeah, it's good if you are using it forever, but if you want just, let's say, you change your mind and you decided to change your ingress controller to something else, yeah, well done. you are on your own. You need to check by yourself all the features if they are covered in your migration step. And of course, it's now coming as frozen features. So Kubernetes now, like every new features that is coming in, like in sense of ingress traffic, is going to be implemented in Gateway API. Which is, on the other half, is CRD-based APIs, which is already great. Although it's getting a bit bloated. It's like very big, as you can assume, because it manages all the different traffic types, HTTP routes, TCP, TLS, gRPC. So the API is getting bigger and bigger, which might be problematic, but it's still like better because there are objects. You can just move it. You can migrate from your one implementation to another. Also, it has a multi-tenancy support. With that, you can just deploy it anywhere. You don't need to care about one namespace and give a specific airbag and control it. You can run anywhere. And also, it's role-oriented. So whenever you have some sort of organization, you don't really worry about it because role-oriented means that you can have a gateway class, which means like on your top of the platform, and every gateway can be ruled by different teams, right? So it all connects to each other to the same controller. Also, it's a flexible and extensible, and of course, it's coming in an open standard of the ingress traffic. So yeah, I want to talk more about Envoy Gateway. Who of you know already the project? Okay, are you using it? Okay, cool. That's nice. Yeah, so it started in 2022 by, I think, 4 companies. They wanted to design a solution that will manage Envoy proxies as an application gateway. Also has a standalone, but first it was totally on Kubernetes. It's extensible to support multiple use cases. And what it really is, like the gateway is a controller. It also has a XDS server. XDS server is a, let's say, bunch of APIs and protocol, how the Envoy configures itself and make decisions on how the traffic should be routed. So it applies the dynamic config, which I set to XDS, and also it allows you to have a static config. So whenever you want to apply some special configuration to your Envoy proxy, you can do it. And then like a controller, so gateway controller manages your proxy to have your traffic flow the way you want to your user app. We chose this solution not only like it has like this extensibility, but we thought that it's really great that it has many deployment modes, so we can really deploy it in many flavors. So you can have like A/B deployments, testing, green, blue, and stuff like that. And also you can run it in a single namespace. You can run in multiple namespace. So it also fitted our, let's say, solution towards LB cluster. But before that, I want to talk like public cloud load balancing, right? So if we assume that ingress traffic and how we control it in public cloud, I probably this talk wouldn't have any more sense because everything seems kind of working there. We have like a gateway API controller or ingress. We just deploy it. We can have also like separate clusters for getting traffic into our user clusters. but like everything works right there, so there is no like a need for that solution we're gonna to build. Like I said, there we have like a probably in our Kubernetes cluster things like a cloud controller manager, which watches for either as like an ingress or gateway API, CRDs like gateways, HTTP routes, and it just manages and provisions external cloud load balancer. Boom, done. But on-prem load balancing is a different story. So as we know, Kubernetes offers no load balancer implementation by default. So it needs a setup for every single cluster, and that applies also for your gateway API controllers or ingress controllers. You need to, when you have like a multi-cloud environment, you have many of the clusters you need to manage, you need to deploy on each of them the same part of things. And also it involves hardware load balancers and IP address management. We like often know the MetalLB. Probably if you are on-prem, you use the MetalLB. Who of you uses the MetalLB? Okay. Good. We also do that in our solution. So about this solution, we're going to talk. We decided to, because we at Kubernetic, we offer many clusters, and they can be run on public, on your on-prem. And we wanted some sort of solution, some load balancing solution that we work across hybrid environments and, let's say, in the same site. So we decided to have a dedicated load balancer cluster with centralized management planes, and for the requirement of getting L7 traffic going, we decided to run Envoy Gateway there. And it's, like I said, it works across different types of clusters. And we started a project that is called KubeLB. It's, like I said, software-based load balancer platform providing capability for centrally managing layer both 4 and 7 load balancing configuration across multiple clusters. But I would like to say mostly it's like a bunch of controllers. So we have 2 controllers. It's mostly focused on architecture of CCM. And you just connect, you have like your LB clusters, and you connect your tenant clusters into it by running CCM agent that will talk to a manager. And also it goes with the architecture of hub and spoke, which is certainly good for network-centric architectures. Whenever you need to manage both control planes and data planes of your network, this now becomes like a more of a standard how you build your cloud designs, that you have like a management cluster as a hub, and spoke are the clusters that connect to it. And right, yeah, architecture of that is, like I said, we have like a management clusters where we installed our KubeLB and the Envoy control plane. And if we want to connect our worker, like we say like a tenant. Tenant John is example of like a cluster that you want. You have a worker nodes, and you deploy the KubeLB agent that will establish connection with the KubeLB manager. And really, it needs only permissions to create the namespace. In this namespace, it will just create the copied configuration from your user clusters. So in the user clusters, whenever you create service, ingress, gateway API, or some secrets you want to, let's say, for a TLS termination, it will just watch for these changes and make sure that the namespace of your management cluster is updated. So how it looks about the L7 load balancing. Let's say we have LB clusters, right? We deployed our KubeLB manager. All is ready to go. We have like nodes ready. We deploy for L7 gateway class. We call it like a KubeLB, and we decided to go with the integration with Gateway API. Please note that you can use any other integration as well. It's just we are using this logic to support Gateway API's specific CRDs. And if you want to connect the tenant clusters, you deploy KubeLB agent. It's called CCM, so Cloud Controller Manager. And then what happens is, let's say on the tenant clusters, you just deploy your backend application. You have backend pods, you have backend service, and you create. You decided to expose it via the gateway and HTTP route. So what happened is a KubeLB agent watch for the changes for gateway and HTTP route CRDs. It creates a backend service, which is a copy of this, like our application, but on the node port. And also, it connects to the LB clusters and create the specific kubelb CRD route that is like mimics the configuration and show how to deploy it. To the manager picks it up, and then it starts onboarding it on the LB cluster. So what it does, manager, from the root, it creates the gateway and HTTP route. And also it creates the tenant LB envoy deployment, which controls the tenant envoy data plane pods. What happens also in between is that when we have like a gateway API controller, like Envoy Gateway, it picks up the changes to we deploy gateway, we deploy HTTP route, and it's like managed by this gateway class. So it picked up and deploys the Envoy infra. So, and what we now want to do is manager knows that we have these two Envoy infra and this tenant Envoy LB pod. So it creates the service. We call it like a bridge service. It's just the plain cluster API, and really what we want to do is to have these endpoints from internal IPs. And we want to know how to manage the traffic from infra to the service, to the tenant envoy, and then back to the tenant clusters. So what we also design is in kubelb manager, we have this XDS control plane. And this XDS control plane configures itself with the clusters and the endpoints. And the cluster is, let's say, the Envoy clusters configuration has the information on which exactly node, because we have their service of type of node port. We have like a direct IP address and its node to know what is the endpoint of, let's say, this service, and whenever the traffic goes, this is like how the traffic goes. So the green dotted line is the way over traffic. So every time the ingress is coming in our LB clusters, it goes to the Envoy infra, then reaches service cluster API. Then we know that the endpoint is this tenant, Envoy LB port. And from that, it checks its own XDS configuration and knows, oh, I should route this traffic to the backend service node port on this node in the tenant cluster. And that's why like a data plane is completely separated from the control plane. So it's just the data that flows between them. So this like a bit like a walkthrough. So this is like what I have deployed in my management cluster. It's a gateway class. It's named kubelb. It's just a standard one. So I will want to showcase you what did happen when I deploy gateway and HTTP route in my tenant cluster. So let's say I have a basic gateway. I deployed my backend application. It's just plain port and service on the port 3000. I want to serve it on this host name, and I want to have direct connection. So what it does, like the gateway in the tenant clusters gets created, it gets picked up, and like I said, kubelb creates their own CRD. So this is called root. It has specific labels to just catch up on a proper service and the pod in the LB cluster. And we copy all the resource from the gateway, and also we keep the reference of the endpoints here as the default because it's a plain service. So what had happened on tenant clusters after this pushing this gateway and backend application, we have deployed we see our application. We have the service backend, and we have the node port, which I said is a copy, but exposed on the node itself. And we see gateway, and we see that it get correct address from the management clusters, let's say LB cluster. And our LB clusters, if we take a look at the tenant, which was created by pushing the gateway configuration on the tenant cluster. We see we created the pod, which is the tenant LB pod, and we see the application service copy for the endpoint for Envoy routing, and we also see the same configuration copy, like a gateway with the correct IP address. That's the entry point for our application. And what happens in Envoy Gateway system. This is like where our Envoy Gateway manages Gateway API CRDs. We have another Envoy. We did it like for simplicity for now. We could take a look at the merging it together and in the future, but for now we just leave it to Envoy Gateway because it does everything with Gateway API and like have a tons of capabilities in there. So what it does, we just deploy the infrapod. The infrapod has also type of load balancer, and we see that the same IP is also there. So every traffic knows that it should reach this pod first. And yeah, if we want to test the connection on the tenant clusters, we just get the IP address of our kubelb gateway and correlate it with the host. And this should be like the outcome. So we see that we reach the correct backend pod on the tenant cluster by specifying IP address, which is on the LB cluster. So yeah, I want to talk about some trade-offs. Running like a dedicated LB clusters means like one more cluster to manage and scale. This can be like a problem, and definitely it is also a problem with the scale, that how we want to scale our clusters when the more traffic is going in, and how many of every our resources, like also kubelb pods, Envoy Gateway pods, we want to be in there. So like I said, initial setup is more complex than cloud-provided LB for sure, and this also requires a new operational mindset. So network is the center of everything, and the data plane and control plane lives in the LB clusters, in fact. So also monitoring and security must be done carefully, but like I said, on the security basis, airbag is fully controlled, so kubelb only has access to the things it should have, and there is no concerns with this. But also, like, I want to tell like benefits overcome those challenges because in the multi-cloud environments, when you have like an on-prem and also public cloud, it's always a pain to offer a new traffic features. And also, like, if you have like to handle certificates or DNS across all your clusters, you're gonna really get into troubles because it's easier to just deploy it like from a single control plane and have it across your all, let's say, region cluster that have multiple, user clusters. And also, like, there are some ecosystem benefits using standardization solution and like adopting open source ecosystem. It's also more convenient setup for organization, and we don't need to bother with many load balancer solution. Like I said, it's always also easier to migrate the configuration. All right, that's all. Thank you. Hope you give it a try. Here are the links to the projects. I hope you get it running, and I hope you will leave some feedback. And there's like a contact points to me. You can reach by mail on the GitHub or also on LinkedIn. And thank you.
Okay, thank you. Any questions?
Yes.
Okay.
Hey, thanks for presentation. Just out of curiosity, how you solve the networking between the LB cluster and the tenant? Is it some VPN or what's the solution?
Yeah, so it was mostly focusing on ingress, so it should reside in the sense of the same network, right? So it's like only north-south, but we had some implementation, for example, with BGP, so you could get the east-west as well. So how it works is just if you have like a top of the rack and have the BGP configuration, let's say that your user clusters has its own, network space, it could easily get routed outside and between each other as well.
Yeah, so then you would do the TLS termination in the tenant, right? You would just...
yeah, exactly.
Okay. Yeah.
But it depends really on the environment. We didn't want to push, the architecture to be limited because, like I said, like service mesh, cluster mesh are a different story. There are also cool projects like KDGB, right? So for the global load balancing, so there is like a tons of solution now. But this is like mostly about provisioning, your load balancer on-prem and helping you. If you have like a tons of clusters, you don't want to fiddle with configuration and each separately, right? So there's like a
Cool, thanks.
Okay, any more? Come on. Okay.
Thanks for the presentation. I have two short questions. The first one, can I have more than one management cluster in my infrastructure, for example, because of redundancy? And the second question, what if I have multiple, let's say, point of presence across different regions? Does it mean that all my traffic is routed through my management cluster, so it's better to have, I don't know, more than one management cluster nearer to my point of presence?
Yeah. Yeah, that's a good question. I think the point of presence is important, so you should put your management clusters nearby. Like I said, it was mostly about getting nearby your region. Let's say you have Europe, so you only want like geography located and also like network connected, right? Clusters with each other. If you want to scale up management clusters, I think you could do it, but you would need to maybe make it more hierarchical architecture, right? So you need to put another layer on top of it, and then you could spread out. I would say that that's okay, because if you have like let's say another manager that connects to each other, you can do it as well, because it's like the same, basic that the data plane will flow the same way, just adding the network hops. That's why I think the point of presence is important to be located in the same region.
Okay, do we have any more questions? Yep.
Thank you. I've got one question about multi-controller here. So you mentioned that, okay, in the previous question, so you can have this management cluster,
Yeah.
more than one, we just scale that. How about the kubelb agent on the target cluster? Is it possible that it connect and push the information to both or more management cluster?
That would be quite difficult because the CCM has like a kubeconfig, right? So you get only the access, whatever you say in that kubeconfig you should do.
Imagine that you just scale this management cluster, the first one. How the information that I just create the service will be populated to those management cluster?
Yeah, so if you have like this setup, like you have this management cluster and you scale your management cluster, I would say just deploy another set of kubelb.
So, okay, each kubelb agent will be connected to one.
Yeah, I would say yes. Only one, the best solution is to connect to one manager. It's like a controller. You don't want to mess up with different. But we also evaluate solutions like multi-clusters runtime that you would control many clusters with but it's like using just the controller runtime, so it just it connects to the only one.
Okay, thank you.
Okay, do we have any more question? Okay. Yep.
Thanks for presentation. I have the question about the DNS. Does the kubelb can support some of the DNS, external DNS, some cloud DNS or something like that?
Yeah, we have a solution that just, it's like deploying the Envoy Gateway. So whenever we use the external DNS, so whenever it's deployed in the LB clusters, it gets converted. So it's also in the CRD route that you can have this information how to use the external DNS.
Okay, thanks.
Because I just limited the talk to have this only one CRDs. We have others, so that's why about the TLS termination as well. You use the sync secrets, so the secrets are there. So there are also all kinds, and I encourage you to just give it a try and leave the feedback on the kubelb GitHub.
Okay.
Oh,
almost. So, anything else? Question? No? So, huge shout out. Thank you.
Thank you.